Using a methodology for troubleshooting. Oh my goodness. In this nugget, you and I get to reminisce a little bit as I take you back in time with me as we take a look at when I worked at Paramount Pictures. I worked with some amazing people and I developed this troubleshooting methodology that has served me for over 2 decades. I want to share it with you in this nugget, and then we'll take that logical methodology for troubleshooting, which can be applied to networks, relationships, your toaster, whatever, and then we'll apply it to a live network as we identify a problem and use the methodology to logically go through using the tools we've already learned in previous nuggets in this course to solve the problem. I'm really excited, so let's jump in. Back in the 90s, I had the opportunity to work for Paramount Pictures in Hollywood, California, and I had a blast. I had a lot of fun, and I had several responsibilities there, but one of them including working with a really great team of technicians. And whenever a problem would come up, sometimes they would solve the problem, which is great, and sometimes they would come to me with a problem. And so I don't know who I learned this from, but it's really helpful, or was helpful and still is. But I learned this 5-step process, 1, 2, 3, 4, 5, that I used all the time. And it was so helpful. I told my team, I said, if there's a challenge or a question you have, feel free to come and talk with me. But just so you know, when you ask me about what I should do, I'm going to ask you the same information. So I would go through this 5-step process with them. And this is roughly the same 5-step process that's in the 1.8 objectives of Network Plus. The key here is not to use this methodology, but to use a methodology. That's the key. Use a process for troubleshooting. So we'll take this process and then we'll apply it to a live network. So the first thing we'd ask, if a technician came into me and he said, there's a problem, I would say, what is the problem? And I would stop there. Do not pass go. Do not collect $200 unless you can describe what the problem is. So sometimes as a user, I'm a user of a computer, sometimes I'll be really animated and excited or frustrated about something not working. And in order for it to be fixed, we have to know what the problem is. Like, for example, there's the old Microsoft story about, I heard it in a Microsoft context, but about 3 people in a car, they're driving along. So I'll drive my car here. So there's the car, and they've got the windows, and that's like a Hummer or something. Anyway, they're driving the car, and the car gets a flat tire. And inside the car, there's a computer salesperson, a computer programmer, and there's also a computer technician. And the technician says, they get a flat tire, so they pull over, and the technician says, let's just replace all 4 tires, and that'll fix the problem. And indeed it would. It's kind of like, just throw everything out, that would fix the problem, but it's not too realistic. The second person is a salesperson, and the salesperson says, let's just buy a new car, and that will solve the problem. And he's right too. Buying a new car would solve the problem. However, both those aren't too realistic. And the programmer said, you know what? He looks around, he says, let's just pull back out on the freeway and maybe the problem will go away. And the reason that's funny is because sometimes a reboot of a system does solve a problem. Something that was out of whack, or DLLs, or some other software that wasn't cooperating with another piece of software. Rebooting sometimes does help, but it's not the solution for everything, obviously. So let's take our network and let's say that we've identified a problem, and let's say that the problem is a PC. So we have 3 PCs on our network. This represents a shared network segment. And of course, physically, this would all be probably tied to a switch with patch cables from the PCs. This is PC1, PC2, PC3. They're all tied in. And we get a call from the user at PC1. So we'll say that's Bob. And Bob says, the network's down. Okay, great, Bob. Thanks for reporting in. Let's talk about what that means. Does your computer have lights on it? Meaning, is the screen lit up? Because maybe the PC's powered off. The PC's not going to communicate on the network if the PC's powered off or not functioning. So great. We could say, is your computer on? Yes, the computer's on. And we could also take the look at the OSI reference model. Remember how the OSI works? At layer 1, we have physical, and then going up the protocol stack, it's all logical, meaning we have addresses at layer 2 and addresses at layer 3 and transport layer 4. But we could say, well, since your computer's on, can you check the cable? Is the cable physically attached? So what we're trying to do is we're trying to gather information and identify what the problem is, if we can. So and maybe that's some of that's why did it happen, but we're trying to gather information. So Bob says, the cable looks like it's in place. I can't log in. I'm not even getting a login prompt for the network. I can't connect to the network or any of its resources. So another next step is we might say, so why did this happen? Now, most of the time, when something used to work and it doesn't now, something changed. And I know that sounds so obvious. It's like, yes, Keith, something changed. It used to work and now it doesn't. But what we could ask the user is, for example, as far as why, we could ask them, when's the last time it worked? So we talk to Bob and say, Bob, when's the last time you were able to log in? And that's really important. I remember I worked at a place called Blue Cross of California, also many, many, many years ago. I got a call down to the Leonard Schaefer. I still remember the CEO back in those days in the 80s. I got a call down to his office, and the secretary there said I can't print. And I can't. So I troubleshot for like 15 minutes. I was like, well, everything looks okay. And then I found out she's a temp. She was a temp in the office, and she didn't have a login. So her computer was on, but she wasn't logged on to the network, so of course she couldn't print to a network printer. So once I discovered that, we resolved it by getting a temporary user account for her to use. But asking when's the last time it worked is really important. And then we can start to identify, what changed since then. So if Bob can't log on to the network, I might want to do a little inquiry, fact finding, and say, well, how about Lois? And how about Susan? These users here. Can they log in? Now, if Bob, Lois, and Susan all are having the same exact issue, I would probably rule out the PCs. I'm going to say, well, it's not the PCs because it's a heck of a coincidence if they all can't communicate at once, but it's more likely what? It's more likely maybe the switch. So this physical switch they're all connected to, maybe it's turned off, maybe it powered off, or maybe there's a configuration change, or maybe the server that they're trying to log into is there's a router here and there's a different network with a different switch and there's a server and they can't log onto that server. So maybe this router is having an issue. So the process of troubleshooting, first of all, identify as clearly as possible what exactly is the problem. I can't save my document, or I can't log onto the server, or I can't cook toast. I mean, it applies to anything. If you can't cook toast, you might say, well, when's the last time you did cook toast? Well, I never have. I don't have a toaster. Well, that's the problem. Now, if they had a toaster, and I use this as an analogy because the troubleshooting methodology can be applied to virtually anything. It's just a process. So what's the problem? Why did it happen? When's the last time it worked? And then we get to go ahead and put our brains in the mix. What are the probable or realistic solutions once we've identified the problem? For example, if all these users here can't communicate and all their machines are down, it's not just Bob, yet maybe I have another group of users over here on this switch and they're all fine, I probably have, maybe it's an interface problem here on a router or a switch that's powered off or somehow misconfigured. So what are the probable or realistic solutions? We could buy a new switch. We could move Bob, Lois, and Susan to other computers. But those aren't too realistic for the real world. Realistically, we'd want to take a look at that switch. And that's also one of the aspects of escalation. Maybe you and I aren't in charge of that switch. We've isolated it. They call us a fault domain. A fault domain is the area where the failure is happening. So we've isolated it to this switch. Perhaps that switch isn't managed by us. We could escalate it. So let's say we do manage the switch for this example. What are the probable or realistic solutions? We might need to look at the switch. And if it was powered off, power it on. And if you power it on, we might have to wait 3 or 4 minutes while it powers on. Now, if it's powered on and there's users who are connecting, and there's some users that do work, power cycling the switch would not be a really good solution. Why? Because we don't want to cause any damage. We don't want to make it worse. So we want to identify what the probable or realistic solutions are to fixing the problem once we've identified the failure or the fault domain, and then pick one. And of course, if we can test it without making it worse, that would be really important. So in the world of routers and switches, here's a router, and here's a switch. I'll label it. They have configurations that tell them what to do. So when a switch or a router boots up, just like a PC, it boots up, and then it runs some power on self-tests to make sure things are okay, and then it loads the configuration. If we are going to change the configuration on a switch, maybe there was a change. We made a change last night. The change is causing the users not to be able to get onto the network. We want to maybe revert that change, but we also want to make a backup. Make a backup whatever you change before you change it again. So we want to be able to restore the switch to the condition it's in now, regardless of what changes we make if we need to. And here's the other thing too. When I worked at Blue Cross of California, again back in the 80s, a long time ago, I take it back. It was EDS, Electronic Data Systems. It was also in the 80s. We were doing a contract for Hughes Aircraft. And so I was installing memory upgrades in these really old Macs, one that had the handle. And I was installing the memory upgrade. So we'd have the user shut the computer off. We'd install the memory upgrade, put it back in place. But I didn't know that Macintosh for anything as far as user interface. And I would have been not wise to take one of those machines and started moving icons or finding out what the trash can does for a living if I'm not sure what to do. So when you're picking and testing solutions, make sure you're comfortable. If you're not comfortable with a change, do not make it. Don't create additional problems. And if you are testing for solutions and you put in a change of anything, and then the problem doesn't go away, make sure you undo that change. Don't leave little troubleshooting droppings all across your path that are going to make the network worse after you're done. So once you've identified what the problem is, go ahead and solve it or escalate it if it's not in your realm of responsibility, and then document it. Make sure you document on paper or electronic copy of exactly what you found, what you did to fix it, and make sure that documentation is available, because the life you save in the future when you have to go look at it again or somebody's looking over your shoulder, it could be your own. So having said that, what we're going to do is we're going to clear off this screen, and here's our troubleshooting methodology that I like to use. And again, what is the problem? Why did it happen? What are the probable or realistic solutions of solving the problem? Pick one, the most realistic one. Also, sometimes if you have two issues or two possible solutions, one takes 5 seconds to check, the other takes a half hour to check, use the 5-second one first, because if it solves it, you're done. So optimize your time there as well, and then once you've identified the solution, implement it and or escalate and document it. So what we're going to do right now is we're going to bring up our live network together, you and I. I will have injected a problem, but you and I together will go through the troubleshooting methodology together and solve the problem. So now we get to put it all to work and verify our troubleshooting methodology. This is the network that we've been referencing over and over again. I wanted to point out some of the finer details of this with you. We have this network right here. These devices are all on one IP network. And remember, on a router, every interface on a router is a different network. So I'm going to redraw that a little bit differently. So the router has two interfaces. So there's one network, and then there's another one right over here. There's another network on this wide area network connection up to R3. And the reason they call it a wide area network connection is because it's geographically far away. See here, these could all be in the same office or same building or same campus. But maybe this is Las Vegas, up here is Reno, Nevada, and we're paying a service provider for a wide area network connection so we can have connectivity between them. So whenever you see a lightning bolt, it usually refers to some type of wide area network connectivity. So we got a call for our troubleshooting methodology, we get a call. We'll say it's from Bob. And Bob says, the internet's down. Okay, so that's what he calls in with. And what do? Well, the first thing to do for us in our methodology is to identify what is the problem. So we ask Bob, what do you mean the internet's down? And he says, well, I can't get to Google. And that's pretty good. We could, write that in tangible terms. So the problem is he can't get out to Google. So what we might want to do is say, well, can anybody get out to Google? And so we might go to another machine on the network, verify that Google works. It's very likely that Google works. Let's together think about the steps that we need to accomplish here with our troubleshooting. So number one, we need to identify what is the problem. So we'll write that down right here. What? And the problem is that Bob can't. Okay, so that's what he calls in with. And what do? Well, the first thing to do for us in our methodology is to identify what is the problem. So we ask Bob, what do you mean the internet's down? And he says, well, I can't get to Google. And that's pretty good. We could, write that in tangible terms. So the problem is he can't get out to Google. So what we might want to do is say, well, can anybody get out to Google? And so we might go to another machine on the network, verify that Google works. It's very likely that Google works. Let's together think about the steps that we need to accomplish here with our troubleshooting. So number one, we need to identify what is the problem. So we'll write that down right here. What? And the problem is that Bob can't get to Google. And we could ask him some other questions. For example, we could say, okay, Bob, you can't get to Google. Can you tell me what your IP address is? So let's start there too. If he's on the phone, we can just have him do a couple basic commands. And check this out. These are commands that you and I already know. So we're going to bring in his PC, and we'll pretend this is his PC, which is right here. And if we wanted him to tell us his IP address, how would we do that? We know this from a previous discussion. So how would we get him to tell us what IP address he has? Well, Keith is tough because he might be assigned an IP address from DHCP, right? Yes, right, perfect. So how do we find out what it is? Well, on the phone, we ask him if he would please click on Start, bring up a command prompt, and it's slightly different based on if he's on Windows 7 or Vista or XP, but it's similar too. And from here, what would we type in to verify our IP address? You got it, IP config. So we have him type IP config, and this is the 10.1.0 network. He's got a 10.0.1 address. Looks good. Looks like he's missing a default gateway too. Wow. So then we could say in our scenario, what's the problem? He can't get to the internet. Now we can get to the why. It's very possible he can't get to the internet because he doesn't have a default gateway configured. And we might ask him, when was the last time it worked? And maybe he says, oh, it worked yesterday, it worked this morning, I got back from lunch and it's not working now. And we want to find out what happened between this morning when it worked and now when it doesn't. So based on him not having a default gateway, and also take a look at the IP address, the first 3 octets of the network based on this mask right here, he's got 10.0.1. The network is 10.1.0. That's like telling somebody that lives on 1st Street and they think they live on 2nd Street. So he's totally messed up as far as where his PC thinks it is based on the IP address. Everybody on the 10.1.0 network has to have the first 3 octets of 10.1.0. That's what gives everybody the same exact street name. So to fix this, we might have him over the phone, because we still could be buildings away from him. We could have him go to Edit in Control Panel. There's a couple of different ways to get here. You can Start, Control Panel, and then go to Network Connections and Network Interface. You go there, or you could right-click on the network icon, go to Open Network Connections. Either way gets us here. So there's our network interface card, and we could just ask him to right-click on that, go to Properties, and take a look at the properties of the TCP/IP protocol suite right here. So you could double click this or click on properties, either way, and take a look at this. He used to have, this morning, all the clients should be DHCP clients. Why is that really important? Because if you're a DHCP client, you're getting an IP address from a DHCP server that's valid, a correct IP address. Because when DHCP hands out IP addresses, it also checks just to make sure that no one else has that IP address before it hands it out. So you're going to get an IP address that's unique. It's going to have the right street name, meaning in this case the first 3 octets are going to be correct. You're also going to get information about a default gateway and also about DNS. They're going to be correct. So somebody configured manually this interface. So it looks like we have a default gateway, but the reason that we're not seeing a default gateway in the command line interface right here is because under the properties, this computer thinks it's on the 10.0.1 network, and the default gateway is on the 10.1.0 network. It doesn't think it has reachability. It thinks the PC thinks I'm on street Y, the router's on street K, I can't even get there from here. So we can fix that by just doing obtain an IP address automatically, clicking on OK, close this, and the PC should automatically in the background get an IP address via DHCP. So now we could say, okay, as far as our troubleshooting process, what's the problem? Well, the problem was that Bob couldn't get to the Google. As far as why, we had an IP address that wasn't compatible with the rest of the devices on this network. So I'm going to just put wrong here. A wrong IP address. And the possible solutions. Okay, so the solutions might include use DHCP, and that should automatically hand him a correct address. And before we actually walk away and say, Bob, you're done, we'd want to go ahead and simply verify that it now works. So now that Bob has an IP address, or we think he does, now we can go ahead and test some basic connectivity. So we'll bring back his computer, which is right here. And let's do a couple basic tests. Now, what I like to do is you could do a ping, and there's 2 schools of thought on this. And we're going to review some commands we've already practiced with, but one school of thought is maybe have Bob try to ping Google. But there's a lot that can go wrong between here and the internet. So maybe we have Bob ping something local, like his default gateway, just to verify that everything right here is solid. So that's what I'm going to do. I'm going to say, Bob, could you do me a favor? Could you see where it says default gateway 10.1.0.1? Could you type in ping, P-I-N-G, and make sure he's got it, space, and then number 10.1.0.1, and tell me what it says back to you. Now, if he does this from a Linux box or a Macintosh, the ping is going to go on forever and ever, and you have to tell him to hit Control-C to stop it. But with Windows, it gives 5 pings, and it has basic connectivity. So you say, great, Bob, you're doing great. So our goal was to identify, what the problem is. Bob can't get to the internet. Why? IP address issue. The solution, make him a DHCP client. And then we can go back and say, Bob, why not try to go ahead and go out to the internet now? So he brings up a browser, and we open up www.google.com. And he still can't get there. We're thinking, wait, stop the truck. Wait a sec. So Bob he couldn't get to Google. He had a bad IP address. We solved that by making him a DHCP client, and he can ping his default gateway, but he still can't get to Google. So the solution that we had, which was making him a DHCP client, we tried it. So in my process, we have what's the problem, why did it happen, what are the possible solutions, try it without doing damage, and he still can't get to Google. So what we might do at that time, let's say that we're at this Linux box right here. We're across the network. If we wanted to try to ping him because we know his IP address now, because we just looked at it, in fact, let's look at it again. His IP address is 10.1.0.53. We could try pinging that device from where we are. And that would verify that he can communicate outside of his local network over to us. So this communication right now is going to go between this Linux box right here and this PC. So I'll bring them back up so we can see. So we go ahead and do a ping. Now, one of the great things about using the common commands that we've been talking about is that things like ping, P-I-N-G, you can use that on virtually any computer. So this is a Linux box. I'm going to go to a terminal. That's simply how you get to the command line interface on Linux. And let's do a ping. And let's ping 10.1.0.53. And that works. That's us on the far side of this wide area network pinging that Windows machine. So what do we know from that? I'm going to do a Control-C to break that or to stop the ping. And let's take a look. So we tried making a DHCP client, and now we have connectivity from the Linux all the way to this. That means the switch isn't the problem. The router, at least for this network, isn't the problem. This router isn't the problem. Now, it could be lots of things. We're trying to isolate the fault domain. So let's use another tool that we've already used before to help verify and identify what the problem is. And the tool I think we ought to run is Nslookup. Nslookup will help us verify whether or not Internet Explorer couldn't open the web page, couldn't get to Google. So let's use Nslookup to verify whether or not Bob is able to resolve the name of google.com to an IP address. Because when we pinged from this Linux box over here, we were using the IP address. There was no name resolution involved. So it could be a name resolution issue. So what is the command? What is the command for us to verify DNS? We had it in a previous nugget. I'd like to ask you, what is the command that we could use to verify DNS? Do you remember? Now, if you're saying Nslookup, great job. And if you didn't say Nslookup, the next time you go through this nugget to review, you'll know it. So Nslookup indeed. So we do Nslookup. I'm just going to go into interactive mode. In interactive mode, the very first thing it's going to do is tell you who your DNS server is, and this is bad news. Look at this. It says Nslookup. Normally it shows you your default server, and the address of my default server is 25.36.96.87, and it couldn't resolve that, and it couldn't reach it. So let's change our server. Do you know how to do that? And if we did www.google.com right now, it would fail. It's going to try to use that server, and the DNS request timed out. So if we want to change the server, we say server and specify 8.8.8.8. So we're changing our DNS server to 8.8.8.8. And if that's a valid DNS server, I think that's Google's public domain DNS server. Now we could try www.google.com. And sure enough, look at that. The DNS server at 8888 responded, and we have the IP address, several IP addresses for google.com, and here they are. Fantastic. So that's how we could use the tools that we've already learned, such as ping to verify basic connectivity. In this case, it's a DNS issue. So how did we miss that? Let's go back to the properties of this client, and under properties of the network interface card, under properties of the TCP/IP protocol suite, oh, look at this. We're getting an IP address through DHCP, but we're not getting the DNS. We're specifying that manually. To fix that, we click this to get DNS server automatically from our DHCP server. Click OK, close. And now how do we verify that it actually worked? I'm going to type in exit to get out of Nslookup, interactive mode. Now how do we verify that we have correct DNS information from our DNS server? ipconfig sounds like the right thing, but it's not showing it to me. Look at that. It gives me the IP address, my mask. It's also giving me the default gateway to use, but it's not showing me the DNS. How do I get that? You remember? You're doing awesome. Keith, just add on /all at the end of ipconfig, press enter, and that will give you all of the information. Fantastic. So here is all the information regarding my network interface card. So, and I named it Nick, by the way, inside Windows. So that's why it shows up saying NIC right here, Network Interface Card. So I've got my physical address. That's my layer 2 address, which is 12 characters, 48 bits worth. Each character is hexadecimal and represents 4 bits. The first 6 are assigned by the manufacturer, are assigned to a manufacturer to use, and the last 6 are the manufacturer to keep unique. DHCP is enabled on this client. Fantastic. And I've got an IP address assigned to me of 10.1.0.53. The mask says that the first 3 octets of my IP address, the first 3 numbers, are the network, like the street name. And because the last octet is not consumed by the mask, not identified by the mask, that means my host address is .53, and that's all well and good. My default gateway is 10.1.0.1, which is this router right here. My DHCP server also happens to be that same router. So this router is acting as a router at layer 3, but also acting as a DHCP server, doing multiple things at the same time. And it also gave me the DNS server of 192.168.1.1, which is on my local network here. I say local. It's not on this subnet, but it's somewhere not on the internet, because 192.168 is a private space. That's in that RFC 1918, one of the 3 categories of private address space. So let's see if I can, let's try Nslookup again. In fact, let's just do it on one line. Let's do Nslookup www.google.com. And it works. And check this out. If we put a period at the end, I want you to think of when you type in a fully qualified domain name, that's what this is, that the root is the final period. We don't actually have to type that in, but if you do, it'll help, just for think of it, it'll help you think of which way the root is. So we have the root name servers, we have the top level domain name servers, and the authoritative domain servers, and www is representing a host, or in this case, lots of hosts. We'll do an Nslookup, and sure enough, I've got all of these IP addresses I could use, and they all lead to Google, and all those databases are synchronized. That's what Google's done for us. So it doesn't matter which one we talk to, because we'll get a response. So let's bring back a browser and go to Internet Explorer, and I'm not going to search. Oh, look. Clippy. All right, www.google.com, and there it is, google.com. Woohoo! So let's just make sure we have all our entire troubleshooting process. What is the problem? Couldn't get to Google. Why? So we did some research. We identified that his IP address was messed up. One of the possible solutions was make him a DHCP client. We tried it. It had a little bit more success, but not still Google. So then we went back and we basically reiterated the problem. We might have to escalate it as well if we can't solve it on our own. But we went back and determined with the tools we learned in these nuggets, like Nslookup, that it was a DNS issue. That computer couldn't correctly access DNS, and so name resolution was failing. So once we've identified possible solutions and tried it, we want to solve the problem, implement the solution, which is important. And then what was the last step? The last step involves documentation. And the last step also could be after you've tried, various things. Now, your solution might be, how do we prevent this user from doing that again? So part of the long-term solution, maybe you have control through Microsoft Active Directory with policy that says end users are not allowed administratively to go in and change the properties of their network. So one of the long-term solutions might be a policy being applied through Microsoft, so through your Active Directory, through your domain, so you're going to prevent that from happening in the future, and also to document what the problem was. Because I'll tell you what, if this user, how did that get changed, really? How did that get changed? Someone went in and made those changes. It was me in this case, so I'm guilty. But if it was a production environment, it was that user, or somebody playing a joke on that user. Maybe somebody downloaded an article and said, oh, you can get more speed out of your network by making these changes, and he made some changes and put back the information incorrectly. So we want to document what the problem was, and next time, check this out. A week from now, if Bob calls again and doesn't have access to Google, we're not going to go through all of this process. We're probably going to go straight to IP addressing, see if that's the problem. And if it isn't the problem, then we can start on the entire process and go through it. Our goal in this nugget was the methodology, clearly identifying what happened, meaning what doesn't work, assess why it's not working, the probable causes, think of a solution or two that might fix it once you've done your research on why it's happening, implement the solution, test the solution, make sure the solution works, and then once it's done, you want to document it and then move forward. I hope this has been informative for you, and I'd like to thank you for viewing.